Have you ever stood beneath the night sky and wondered where it all began? Not just life on Earth, but light itself, those ancient glimmers of fire suspended in the darkness? What are they? How did they get there? And what happens when their light goes out? I remember lying on the roof of our old house, wrapped in a blanket, the air cold and still. One star above seemed brighter than the others. It shimmered like a secret being whispered across the void. My dad looked up beside me and said, "That star might already be gone. You're looking at ancient light." That was the night I realized, the sky isn't just a view, it's a memory written in light. Every star you see has a story, a dramatic, fiery story of birth, life, and a death so powerful it can rewrite galaxies. So tonight, let's journey not to a planet, but to the life cycle of the universe's oldest storytellers. This is the tale of stars. Nebula, where stars are born from dust and ghosts. It all begins in a nebula, a vast ghostly cloud of dust and gas, often stretching for hundreds of light years. These are star nurseries floating in space like cosmic wombs, but the material inside them, it's ancient. It's the ashes of stars that lived and died before. A nebula is recycled stardust, a graveyard and a birthplace rolled into one. In these cold, dark clouds, gravity is the artist. It pulls particles together, forming dense clumps that grow heavier and hotter. What starts as a whisper of hydrogen becomes a roar of collapse. Over millions of years, the center of the clump becomes a protostar, a growing, glowing infant star. As pressure builds, temperatures rise past 10 million degrees Celsius, and then something magical happens. Fusion ignites. Hydrogen atoms smash together to form helium, releasing immense energy. And for the first time, the darkness is broken by a brand new star. No explosion, no fireworks, just a quiet light blooming into existence, one that may shine for billions of years. The main sequence, a star's golden years. Once fusion stabilizes, the star enters its main sequence phase, the longest and most stable part of its life. This is where our sun is today, peacefully fusing hydrogen into helium. The star is now locked in a delicate balance. Gravity pulls inward, but the energy from fusion pushes outward, creating an internal tug-of-war that holds the star steady. These stars are cosmic factories, forging elements in their cores. Hydrogen becomes helium, helium becomes carbon, then oxygen, then neon, and so on. You and I, we're made of this stuff. The iron in your blood, the calcium in your bones, the oxygen you're breathing right now, all born inside ancient stars. We're not just stargazers, we're descendants of stars. Some stars remain in this phase for tens of billions of years. Others, especially massive ones, burn bright and fast, living for just a few million years before racing toward their final act. The red giant phase, a star's midlife crisis, but way more violent. Eventually, a star runs out of hydrogen. Fusion slows, the core begins to shrink and heat up, and the outer layers expand dramatically. The star becomes a red giant, a swollen, aging monster that glows with a deep crimson hue. Our own sun will enter this phase in about 5 billion years. It will expand so much that it could swallow Mercury, Venus, and even Earth. The peaceful warmth we know today will become an inferno. But inside that giant, something fascinating is happening. The core is hot enough to start fusing helium into heavier elements, carbon, oxygen, and beyond. The star is not dying quietly. It's fighting, clawing its way toward the inevitable. For massive stars, this process moves faster, more chaotically. They burn through elements like a dying fire feeding on its last logs. Carbon, neon, magnesium, silicon, until finally iron is created, and that's when everything collapses. Two endings, one gentle fade, one violent death. A star's final chapter depends on its size. Smaller stars, like our sun, die peacefully. After becoming a red giant, they shed their outer layers, forming a glowing shell of gas called a planetary nebula, an ethereal, colorful halo suspended in space. What's left behind is a white dwarf, a hot, dense, Earth-sized core that slowly cools over billions of years, eventually fading into a black dwarf, a cold ember that no longer shines. But massive stars, those 8 times heavier than our sun or more, don't go quietly. When their core fills with iron, fusion stops. Iron can't release energy through fusion. Gravity wins. The core collapses in less than a second, and then, boom! A supernova erupts, releasing more energy in 1 instant than the sun will emit in its entire lifetime. Light from the blast can outshine entire galaxies. For a moment, the universe watches as a titan dies, its last breath written in cosmic fire. And from this violence comes beauty. The explosion scatters elements like gold, uranium, and platinum into space. These are the materials that make planets, moons, and wedding rings. Stars die, but they leave gifts behind. What remains? Neutron stars and black holes. What survives after a supernova? That depends on just how massive the original star was. Some leave behind a neutron star, an object so dense that a single teaspoon would weigh over 1 billion tons. Neutron stars often spin rapidly, shooting beams of radiation like celestial lighthouses. These are called pulsars. They spin with terrifying speed, hundreds of times per second, their rhythm a steady echo of a dead star's heartbeat. But if the star was even more massive, the core collapses into a black hole, a region of space where gravity is so strong that not even light can escape. A black hole doesn't shine, it consumes. We can't see it directly, but we know it's there, warping space, bending time, pulling in anything that wanders too close. Some black holes are leftovers of dying stars. Others grow so large that they anchor entire galaxies. At the center of our own Milky Way, a supermassive black hole holds everything in orbit, and yet we still don't fully understand them. Are they the end of stars? Or the beginning of something beyond our current imagination? The cycle of stardust. Nothing is wasted. And here's the beautiful truth. Nothing in the universe is wasted. When stars die, they don't disappear. They become part of the next generation. Their ashes drift through space, merging with other clouds of gas and dust. New stars are born, new planets form, and sometimes those planets give rise to life. You are stardust, bound by gravity, lit by electricity, and made conscious by chance. Every atom in your body was forged in a star that lived, burned, and died long before Earth ever existed. You are, quite literally, the universe becoming aware of itself. Final thoughts and call to adventure. If you found beauty in this story of cosmic birth and death, if the thought of ancient stars burning, dying, and becoming part of you moved something deep inside, subscribe to Interstellar Journey, because this is only one story in the universe's vast library, and together we've only just started reading. So the next time you look up at the night sky, remember, those aren't just stars. They're memories. They're ancestors. They're time capsules, shining across billions of years to whisper something very simple to you. You are not alone. You are part of us. Until next time, keep wondering, keep dreaming, and most of all, keep looking up.